Hello and Assalamualaikum. My name is Nasuha and my metric number is AE18014. And today I'll be presenting on my final year project 2, which is interpretation and translation of Malaysian Sign Language for hearing impaired individuals using Matlab. And here are my details, which is my name, as stated earlier, Nasuha and my metric number. I am an electronic engineering student in mechatronic. Okay, firstly, the introductions. Okay, so for the following statements, okay, according to WHO, which is World Health Organization, over 5% of the world's populations, or 430 million people, experience hearing disabilities, be it minor or major ones. For people born with these disabilities, their primary form of communication is by sign language. However, not everyone knows sign language. Thus, this project is done as an effort to help lessen the gap of communication between sign language users and non-sign language users. Okay, so here are the objectives. Firstly, to create a system where it is able to translate the gestures from Malaysian Sign Language that are shown to it. Second, to identify how the image processing techniques used are able to aid in identifying as well as translating the Malaysian Sign Language. To evaluate the different parameter settings and how it affects the system's accuracy. And lastly, to evaluate the effectiveness of the systems by checking whether the system is able to accurately detect the gestures. Okay, next is the project architecture. Okay, so here are the project architecture. Firstly, we will have the input image being put inside the system, and then we have the images pre-processing step, which will later on be explained. And then after we have pre-processed image, there will be features extractions that will be done by the system. So at features extraction, there are essentially two phases, which is system training and system validations. So the system will go through our input images through the system. Firstly, it will train, and then it will go to the database, and then the system will validate the database, and then it will go on a loop for as long as it's stated in the system settings. After it has been trained, then we will test the accuracy by using this gesture recognition system. Okay, next, dataset and pre-processing method. Okay, so for dataset, essentially, there will be three types of datasets that will be used in this project. Firstly is the training datasets, which is the initial data that are used to train the system. And for this project, we'll be using 70% of the entire data that we have. So next are the validation datasets, which is data that are used to optimize model parameters. In this project, it consists of 30% of the whole datasets. So meaning for the whole dataset that we have collected, 70% will go to training datasets and 30% will go to the validation dataset. For the testing dataset, it is used to get an unbiased estimate of the final model performance. This will be used at the testing part, which is after the model has been trained. Okay, so in this project, its value are the same as validation datasets, meaning if for the validation dataset, if like for one gestures, it use 70 data for it. Then for this, for the same gestures, it will use 70 testing dataset as well. For this testing dataset, it is not a part of the whole dataset, which is like where the training and validation dataset come from. It will come from another source, which will later on I'll explain later. Okay, so here is the information for the training and validation datasets. Okay, so for FYP1, I have collected the datasets for the vowel character A, E, I, O, and U. Which here is an example of the datasets. Okay, so here are the things to note. Okay, for each gesture, there will be two options for background, which is one is the light colored, and next is the black colored or dark colored. As you can see from here, the A have like A is in light colored background and E is in dark colored background. But that does not mean A only have light colored. No, it means A have both light and dark colored background data sets, same as with the other gestures. Okay, so for it, and next one is that each dataset will have left and right hand version of it. Meaning for A there will be I've collected A using right hand and also have collected A using left hands. Okay, so next is for FYP2. Okay, I have add an additional dataset which are consisting of gestures for number 1 to 9, which here is the examples for it. Okay, so same as FYP1, there will be two sets of background for each gesture, which is light colored and dark colored. And each dataset will have left and right hand version of it. Okay, so from both FYP1 and FYP2, in total there are 3,135 pictures available from the dataset collected. But for each gesture, the numbers of it are not the same, meaning the value of each dataset varies. Okay, so here are the image pre-processing steps. Okay, so first I've done resizing for the dataset because the pre-trained network that I'll be using are AlexNet, which the input layers only accepts a 227 by 227 pixels of image. So here I have resized the image. Okay, so I also done augmentations for the dataset, which is rotations as well as scaling, and another one is reflections. Okay, so for the rotate, the picture will be rotated randomly at the angle of negative 90 degree to 90 degree maximum. And next is the rescaling. The picture will be rescaled to twice of its size maximum. This is done so that I can give the system more variations of it on each gestures. Okay, so here are the parameters set up in here. So before I can start training the system, I have to specify on these parameters and test which combinations of parameters that can give me the best accuracy on a short amount of time. So the parameters that I set are epoch, initial learning rate, and min batch. Okay, so from all of these tests, I've opted to use 10 epoch. Initial learning rate been set to 0.001 and mini batch is to 100. Okay, so from here I can get the validation accuracy and testing accuracy to be 84.01%, and the time taken is 40 minutes and 42 seconds, which if we were to compare amongst all the other results, we can see that it is the best possible parameters to choose. Okay, here are the demonstrations, which I will open up the video of the demo. Okay. Hello and Assalamualaikum. Okay, now you can see that I'm trying to do the number 1. So, okay, next number 2, we can see that both of these gestures are easily detected. Okay, next is number 3, if I'm not mistaken. Yes, number 3. Okay, so this is easy to detect too. But it keeps on getting changed with the others. Okay, now it's number 4. Number 4 is quite hard to for the system to detect. Okay, but I got it. Yeah, but the system able to detect it after change of lighting. And now it's number 5. Number 5 is the hardest one for during this demo for the system to differentiate it among the other gestures. We can say that during this demo that the lighting changes every time the laptop moves, and that can affect the the gesture system, the gesture detection system. Okay, so now it's number 6. So for number 6, okay, after a couple of tries, I finally get the number 6, and now it's 7. 7 is quite easily detected, and now 8. 8 is also easily detected, and now it's 9 if I'm not mistaken. Okay. 9 is also detected after a couple of tries, and now it's the vowel turns. Okay, now this is the gestures for the character S. Okay, so we can see that the system are able to detect it, but sometimes can't mistake it for other gestures. And now E is very easy to detect, and now I, as you can see here, it keeps on getting mixed up with number 1, right? Okay, so next is O. You can see that it keeps on getting mixed up with U, and after finding a couple of tries, we can see that we got it. And then the last one is U, which is easily detected. Okay, now here are the results and discussions. Okay, so for the result and discussions, as you can see earlier from the demo, if we were to test the accuracy by simply describing how each gestures are tested, we will have no specific way to address the accuracy. So how I test the accuracy is by I'll be using a testing data set in 3 different situations, which is natural lighting and plain background for the first type of data set. The next one is plain lighting and complex background. And the third data set is the data set that are taken at the same place, so that it can have the same lighting and same background as training data set. Okay, so here are the results from the accuracy testing. So we can see here for the test data set with plain background and natural lighting, we can have the training accuracy, the testing accuracy, sorry, this is wrong, testing accuracy to be 35.82%. For the test data set with cluttered background and backlighting, I can have a total of 17.058% testing accuracy. And the data set, which is test data set taken at the same places as the ones from retraining and validation data set, we can obtain 67.48% accuracy, which is the highest among the 3 type of data set. Okay, so from what we can see here, if you were to compare each types, we can see that factors like illumination level as well as type of background do play a huge role in determining the system accuracy. So as we can see, for the second dataset, which have bad illumination level and complex background, is bound to have low testing accuracy, right? Because the features are not, because the system are not able to detect the features of each gestures properly. Okay, so lastly is the conclusions. Okay, so for the conclusions, the systems are able to translate the gesture detected into its respective data sets. And next is by changing the parameter setting before the training the system, the accuracy of the system and its training time can be affected. These are done by the setting up of mini patch, epoch, and initial learning rate. And then next is external factors like illumination level and complexity of the background plays a huge role in determining the system accuracy. And lastly, a couple of changes can be done as to further improve the system, which is done by adding more variety of data set, such as different backgrounds, skin tone, size of hand, and etc. And okay, so that is all from me. Thank you.